Hello everyone, in this video I'd like to go over the hands-on exercise with Holoviews. And again, this is lecture 13 notebook. So the first thing we're going to do is we're going to import all our modules. You should see this icon here, which means that everything is installed correctly. For some of you, the rendering wasn't working, but hopefully that is fixed by now. If it isn't, please do come and find me. Alright, so let's start with a hands-on exercise, and we're going to be reading the number of cases of measles and pertussis in the US over time, which is a data frame that has year, week, state, measles, and the cases of pertussis. So the first thing we want to do is we want to calculate the total number of cases per year and plot it. For that, what we're going to do is we're going to use our trusty group by, and we want to group by year and then get the sum. You see this gives us measles, pertussis in the week columns. So the week we don't really care about. We only care about the measles in this case. So we're going to use the LOC keyword and just get the measles. And there we go. So now we get a series. And with that, we can just plot it. And this is what pandas plotting will do. I'm trying to remember if we haven't imported Seaborn, but Seaborn will make the plot slightly prettier than this. However, today we're just going to look at interactivity, and that we get for free by importing the hvplot module. So let's try this plot again. But this time, instead of plot, let's call hvplot. There we go. So now you see we can, if we get the cursor on top of the line, we see the values. We can again zoom in, pan, reset the plot. So you see the fonts have changed a little bit. Some choices have been made for us about the labels and so forth. All these are customizable with the opt keyword, so .opts, and that again allows for a lot of flexibility in terms of customizations. So one thing I want to talk about is that if we save our plot, let's say it's P1 here, you see we're not seeing anything because everything is saved in this P1 plot, P1 variable. So the P1, if we decide to show it, it actually has the plot itself. Now, we want to add a line, a vertical line in 1963 that designates the year the vaccine was introduced. So we're going to use the HVV line. So before we do that, let's take a look at the documentation as we always do. All right, so you see it has a bunch of things here. What's important is that we get, because it's a vertical line, we only get the X coordinate that we want our string to appear. And after that, the parameters, you see that it's the extents, cdims, kdims, vdims, label, and all those things. So we've got a number of different, again, options that we can use. At the simplest, the vertical line takes the x index, right? Oops, 3, there we go. If I can type. So if we just plot it, you see we don't see anything because by default the x and y axes of Holoviews will just give us from 0 to 1. If we did, let's say 0.2, now we see the vertical line, but we don't want that. So we want to overlay the vertical line on top of the P1 plot. And the way to do this is by multiplication. So P1 multiplied, and there it is. Blue color, we don't want that, so let's change the color by using again the opt keyword or methods. And this one will have a bunch of different parameters here, so take a look at the documentation. So here we got our vertical line. So easy. Again, overlaying the plot with multiplication. If we have addition, then it will put the plot side by side, and you saw from before that the HVV line doesn't really give us anything, so it only makes sense in this context. So now let's add some text, because we're going to overlay the text. Let's copy this first. We're going to overlay the text, which means that we need to use again multiplication, and Holoviews also has this tab here, text. So if we look again at the documentation of HV text, we see we get an X coordinate, Y coordinate, and the text itself. So these are the three required parameters for this function, and then there's a number of other ones. The one I want you to pay attention to is H horizontal align. By default, it's center, but because we don't really want to, let's try it like this and see. So let's put it at 1964, and let's do something like around here. So 27,000, and the text is vaccine introduced. So the center horizontal alignment, you see that the 1964 corresponds to the center of the string. We don't want that. It's a little bit, I mean, I'd like the vaccine to be on this side, on the right side of the line. So let's align to the left, which means that the first string, so the x value would correspond to the first string here by aligning it to the left, meaning we're aligning the index. So, for example, if we do right, you'll see, there we go. So D, the last string, actually aligns with the index here. So let's go back to left. So again, an informative plot, interactive plot with essentially, what, 2 lines of code. So let's group the data by year and state and create a dynamic plot with a drop-down menu for each state. And one of the things that we did in class with some of the groups is we used HV table to do that according to the economic drop-down example that we found in the Holoviews documentation. There's also the dynamic map that we can do, similar to the demo that we showed in the lecture with HoloMap. However, there's a quite a bit easier way to actually accomplish this. But again, if you haven't seen it anywhere, it's a little bit difficult to figure out that HV plot can do this. So first things first, let's try to aggregate the data by year and state. And the way we can do this is we can provide a list to the group by function, and then we're going to do some. So let's see what the aggregate looks like, and we get what we expect. Now, again, let's get rid of, let's just grab, actually no, let's just go here, and then let's just only grab everything, and also just measles. Here we go. So this is our aggregate plot, our aggregate data frame. Now, the one thing we can do here is use HV plot, but with some of the keywords change in order to get the drop-down menu. So the first thing we're going to do is called HV plot. So let's see what this does. Okay, so you see all the lines here for each state, they're kind of combined together, so really not informative at all. But if we think of this as a grouping operation, right? Because we want to group our plot or the data that are contained within plot for each state. We can see them as groups, which has a direct correspondence with the group by operation that we already performed. So there is a group by keyword here. We can say state. So let's see what this does. Okay, so this looks better. Now you see, again, we get for free the drop-down menu. So Holoviews will assume if we decide that we want to group by the plots, or the data actually, because the aggregate, one thing to know about these objects is that not only they contain the plot, but in essence, they're an object that creates a bunch of, that has a bunch of methods, but it also contains the data that are used to render the plot. And by having a keyword like group by, what it does is it groups the data and then creates plots. So instead of saying, hey, let's calculate the mean, let's calculate the sum for each of these groups, what it does by default, the only thing it can do is calculate the plot, render the plot essentially. So we can be a bit more explicit, and we can provide the column name for the x-axis. But again, now we can do this. So you see the rendering is pretty fast. Now, one thing that's going to demonstrate, hopefully, that the HV plot, the aggregate object, as it's converted into a Holoviews object, one thing that's going to demonstrate that it contains the data, if we use this keyword here, dynamic, by default it's true, which means that whenever we change something on the plot, it dynamically generates the data. So sometimes that means that we don't have to store in memory the data for all the plots. So for something that contains lots of different key dimensions or lots of data, it makes sense. So it will become faster to render. However, sometimes, you know, we don't want to, if the calculation is expensive, the grouping is expensive, we don't want to do it every time we update the plot. So we want to use dynamic false, where we pre-compute. And in this case, what it's going to do is it's going to pre-compute where the data goes according to the state each row belongs to. So you see that it's going to take just maybe, you know, a split second more, if you can notice. Actually, a little bit more, maybe like a second or two. So you saw that it was a bit slower, and that's because it stored in memory. So it pre-calculated all the plots for each state. And essentially, we're not going to notice any difference in speed, but the data are already pre-computed. So again, there's multiple ways we can do this, but this is the easiest way we can do this. And because it's a Holoviews object that has the data, let's try something here. Let's try to save this. Now, why don't we try to actually put the vertical line that we did from before, 1963, opt color, and let's see if this works. And again, it's calculating everything, and there it is. And again, if we take out this, just put dynamic true, just to make it a little bit faster. You see how much faster it renders because it does things on the fly. There we go, Kansas. So you see now that we can do the same thing by overlaying other elements, and each time we update the plot, these other elements are also overlaid. But what this tells us, and actually let's delete this part. So if we want to put the plot of Texas and New York side by side, there's a couple of ways, right? You can essentially grab the data frame and keep only the New York and Texas, and then plot them side by side. That's one way to do it, legitimate. Another way would be to realize again that this object here contains data, which means that we could select the actual state. So let's do P2, oops, Texas. There it is. So again, and this is why group by and the column indexing works as well, because it does contain the data. So by doing P2 Texas, we actually get the same plot from P2, but extracting only the part that corresponds to this column, which in this case would be Texas, or not column, but I guess a query. So we're querying Texas. Now, I don't like this measles here, so we're going to use relabeling, and we're going to name it Texas. There we go, something better. Another thing we can do is we can create new dimensions, I guess, you can call them. And we can say something, you know, so there's things we can do with this. Oh, well, it's not finding it now, but we can probably look at the documentation. Let's see if we can do this. There we go. So it's a property, so we really can't see the doc string here, but essentially take a look at some examples, but you can see how we can redefine dimensions and essentially change the range of these, the x-axis or the y-axis. All right, so let's put New York next to this. So the same way here, and let's relabel. And here we go. And again, if we zoom into one, we zoom into the other one as well. Alright, now select 4 states and plot them on all in one plot. And this one we're going to do again by using the aggregate now data frame, because we can select all the locations, and let's select some states. So again, let's grab New York, Texas, Maine. I'm not going to type Massachusetts, so let's try something shorter. Let's see, oops, Oregon. It's a little bit shorter. Alright, so we got this. Again, you see we only got these 4 states, and then we can use hrplot. Now, if we plot this, you see again we get all the lines together. So not really useful. But similarly to Seaborn having the keyword hue, here we have the keyword by. So we're telling it, hey, just give us separate lines by state. And it will do what we expect. It will put a legend, it will put the colors here, and again we can see if we hover over the lines, we can see the data and also the state they belong to. Okay, finally let's convert this into a bar plot. So let's just copy this line here. And there's a couple of ways we can do this. We can either do dot bar here. The other way would be to just change kind into bar. Not really a huge fan of this, but didn't really look well. Did this work? I don't know. Let's find out. So one way to find out is to zoom in to see what was going on here, why it's showing up black, when in fact it actually is not black because it's just too close together, so too much data. So you see that we still get the different colors, but then we do get this overlay of the states here. So perhaps horizontal would be better. So bar H. Okay, we still get this thing here. So let's zoom in. I think these are just too many data points. So let's just grab something. Let's see, 1990 to 1994. Okay, better. So at least this, you know, I mean, obviously if you had all the data, you're not going to show them like this. This would be a much more cleaner plot. But if you have limited data, then a bar plot might make sense like this if you have these multiple categories. But again, you see that depending on how we manipulate the data frame, then hrplot will know what to do. So the index will become the x-axis. If we're looking for a bar plot, you know, that has 2 indices, then it will use those to create these groups. The group by works same way as pandas, essentially, to create drop-down menus. If it's a categorical variable, if it was a continuous variable, we'll create sliders. And finally, again, this is the takeaway from this, Holoviews objects contain data, which makes it much easier to do things. For example, if we already had created a plot that we want to extract something from, we can just do it as simply as this. Alright, and that covers it for the hands-on exercise.